Another example here, find dy dx where y is equal to the square root of 3x cubed plus 4x plus 1. Now, in order to use the generalized power rule, we will have to convert this radical function to a power function. So from square root of 3x squared plus 4x plus 1, it becomes now 3x cubed plus 4x plus 1 raised to 1 half. So should we have 1 here? Okay, so we will use the generalized power rule. 3x cubed plus 4x plus 1 raised to 1 half. So using the generalized power rule, we will evaluate the derivative of the outer function. So we will have 1 half here as our base times the inner function, which is 3x cubed plus 4x plus 1. We will not change anything at all here. And then 1 half minus 1 according to the generalized power rule. Next is the derivative of the inner function, 3x cubed plus 4x plus 1, which is 9x squared plus 4. So this is 1 half times the quantity of 3x cubed plus 4x plus 1 raised to negative 1 half times 9x squared plus 4. So to simplify this one, so this is 9x squared plus 4, and then since this is negative 1 half, so we will put that in our denominator. So that's here 2, and then this is 1 half, so this is square root of 3x cubed plus 4x plus 1. So this is the answer. Okay, so we will differentiate y is equal to sine 3x raised to quantity squared. So if you've noticed that there are two inner functions here. So the outer function is obviously this. That's the 2. Well, the inner function is the sine 3x. And you can see that the inner function of sine 3x is the 3x. So there are two inner functions that should be evaluated. Okay, so using the chain rule, so that's the outer function, derivative of the outer function 2 times the sine 3x raised to 2 minus 1, that's 2 sine 3x, times the inner function, which is the sine 3x. So derivative of sine 3x is cosine 3x. And notice there is a 3x here in our trigonometric function, so it is the inner function of our trigonometric function. So we will get the derivative of 3x. So the ddx of 3x, which is equal to 3. So that's 2 sine 3x times cosine 3x times 3. So that's equivalent to 6 sine 3x times cosine 3x. And this is the answer. Another example, we will differentiate 3x squared minus 5 quantity cubed. Okay, here you see the chain rule or the generalized power rule. So that's the outer function. So that's 3, and then 3x squared minus 5. We will not do anything here at all. And then 3 minus 1, that's 2. So that's 3 times 3x squared minus 5 raised to 2 times the derivative of the inner function with 3x squared minus 5, that's 6x. So the final answer, that's 18x times the quantity of 3x squared minus 5 raised to 2. This is our last example. We will consider the functions y is equal to 3u squared plus 4u, and our u is equal to x squared plus 5. We will differentiate the function. So find dy dx. So according to our chain rule, the dy dx is equal to dy du times du dx. So the dy du of 3u squared plus 4u times the du dx of x squared plus 5. So 3u squared, derivative niya is 6u, derivative of 4u is u. Derivative of x squared is 2x, derivative of 5 is 0. Now, the u here, we will get it back to its original value, which is x squared plus 5. So 6 times x squared plus 5 plus 4 times 2x. So that's 6x squared plus 34. And then times 2x, so the final answer is 12x cubed plus 68x. So that's all the topic for higher order derivatives and the chain rule. I hope you have learned something from this lesson. God bless for your final examination, and please study very well. God bless and goodbye.